Welcome everyone. Can you imagine merely by watching a system you can freeze it in time? Merely by watching a system or merely by watching an object, can you freeze that object in time? That means, what is the question? Can you understand the question? That means whether the time for that object which you are watching can be stopped or not. That is the question. And that is the topic of discussion in today's video. Quantum Zeno Effect. Quantum Zeno Effect. Zeno, this is according to the name of an ancient Greek philosopher. Okay, his name was Zeno. And he was famous for his paradoxes about motion and time. And according to his name, this name was given to this effect known as Quantum Zeno Effect. That means it is a quantum effect actually. Okay, and it is also related to time. That's why this is called Quantum Zeno Effect. And question is same. Question remains the same. Is it possible just by observing the system or just by watching the system, the time of the system can be stopped or not? That is the question. Because this thing happens in quantum systems. Scientists have experimentally got such results for trapped ions, for ultra-cold atoms, and for other quantum systems. Scientists have already got such results. You know, if you have already studied quantum mechanics or quantum physics, then you know that a term is there, quantum superposition. What is quantum superposition is actually? You know, any particle in the quantum system, whether it is an electron or proton or any atom. So if you talk about a quantum system and if you concentrate on only one particle, then that particle exists in superposition. That means multiple states exist together. Means multiple possibilities are there. Multiple states exist together in case of quantum superposition. And in case of any quantum system, this is the truth. And those states can be described by the mathematical equation known as Schrödinger equation. That means for all the particles, wave function exists. And you also know that, so this is quantum superposition. And you also know that whenever you observe a particle, in that case, the wave function of the particle collapses. Means whenever you are watching the particle or observing the particle, you are essentially collapsing the wave function of that particle. In that case, the particle exists in a fixed state. Okay, in that case, the particle exists in a fixed state. That means whenever you are watching a particle or whenever you are watching a quantum system, you are essentially forcing the particle to exist in a definite state. So in that case, whenever you are doing this thing, whenever you are watching that thing, maybe you are watching for continuously, or maybe the watching is frequent enough. In both the cases, same things happen. And whenever you are not observing, nobody is observing the quantum system, in that case what happens? The quantum system evolves naturally. Okay? And these are known fact in the realm of quantum physics. These are known fact. So question is, whenever you are observing the system, so the particles remain in a definite state. That means, are you really stopping the time of that particles or that quantum system? Is the time stopped for those particles or for those quantum systems? That is the question. So answer to this question is no. You are not actually stopping the time that way by observing. You are restricting the system to evolve. If you take the example of radioactive decay, in that case also, if you make frequent measurements, in that case the decaying process, the natural decaying process is slowed down. Because that is also a quantum system. The process is quantum process. I am talking about radioactive decay. So if frequent observation is made or frequent measurement is made, in that case the natural decaying process is slowed down, and this also has been proved scientifically or experimentally. Okay, experimental verification of this is this exists actually. So what is the conclusion? Conclusion is what for the observer, time is not stopped. For the observer, you are observing the quantum system. So for you, actually time does not stop. It seems that time stopped for the system which you are observing. It seems, not actually it is happening. Okay, but it is not just a scientific curiosity. Okay, now you know the truth. Time actually is not stopped. But what happens, you know that thing right now. Whenever you are observing the quantum system, you are collapsing the wave function. That means by using the same technique, you can manipulate quantum states, right? Scientists are very clever. After knowing this thing, they have been able to manipulate quantum system just by observing it, just by taking frequent measurements. Okay, and manipulation is required in the field of quantum computing. Say for example, qubits, you know, quantum bits. Quantum bits are known as qubits. So to stabilize qubits, you can do the same thing. Okay, you can do the same thing to stabilize the qubits or the quantum bits. Manipulation of quantum states is required in that case. Okay. So in many cases, in many experiments, in the experiments of particle physics, in the experiment of quantum optics, these are required. Manipulation of quantum states are required. And those things can be done by using this technique, Quantum Zeno Effect, by using this effect. Okay, so in many cases, again in case of MRI, you know that MRI is what? Medical imaging technique. So for precisely taking the images of the required parts of human body, you can do the same thing here also. Okay. So that means there are so many implications in the field of science and technology. Since just by observing or just by watching the quantum system, you are able to manipulate the states of the system. So you can take advantage of this. And accordingly, you can devise technologies. Again, there are so many philosophical implications of this effect, but for those philosophical implications I will make a separate video, okay, not in this video. Actually lengthy videos are not desirable by any audience, but this is my experience. So for philosophical implications I will make a separate video. Anyway, so this was all about what? This was all about Quantum Zeno Effect, right? You know Zeno paradox. That is actually a famous paradox about motion and time. So many paradoxes are there. But this is not paradox. Quantum Zeno Effect, this is not a paradox. This is reality. Okay. Anyway, so this was all about the topic. And this is the end of this video. Thank you. Thank you for watching this video.